Oh, hey guys. So what we're doing is we're doing a L'Hopital's rule here, and well, we've got a limit as t approaches zero, and here we've got an exponential over a linear function. And if I go ahead and plug my zero in, I'm going to get e to the zero minus one. Well, e to the zero is one, and one minus one gives me a zero. So that's what I've written over here. So this up the numerator's limit is zero. The denominator's limit is also zero because 3 to the 0 is also a 0. And if you're going to be taking a AP test, remember, you want to go ahead and write each of these limits out separately and write them out as being 0 because you need to state that the conditions exist in order for you to use L'Hopital's rule. L'Hopital's rule needs a limit of a 0 in the numerator and the denominator, or something like infinity over infinity. It thinks there's different variations. This one's a 0 over 0. So what we're going to do is e to the 0. So now, basically, since we've established that these are both 0, I can use L'Hopital's rule. L'Hopital's rule states that I go ahead and I take the numerator and I differentiate it, the denominator, and I differentiate it as well. Okay, and so e to the 4t is e to the 4t times 4, because I would use the chain rule there. Because remember, the derivative of e to the 4t is e to the 4t, and then I multiply it by the derivative of this exponent position here. Okay, and then I subtract 0 because the derivative of 1 is 0. Finally, the derivative of 3t is going to be a 3. And now this is my new limit that I want to test out, where t of 0, as I make t approach 0 here, I'm getting e to the 0 times 4, or 1, this is a 1, times 4 over 3, giving me a 4/3 on my limit. So previously it was a 0 over 0, and we discovered then the actual limit is going to be 4/3 due to L'Hopital's rule. Okay.